Hello, everyone. Are you here? We are a bit waiting Nadia and Carmelo, I think.
Hi, everyone. Nice to see you. Hello, Anna. How are you? Can you hear me?
Hello. Nice. Yes, sure. Great.
Great, guys. So we are continuing with our educational online program, Urban Modularity, that we've started just a couple of days ago with the great presentation of Anna and Artyom, who are the curators of this program. And today we're having the second webinar in our educational program with Carmelo Zappulla, who is joining us right now. And we will start his presentation, I think, in a couple of minutes. So while he's joining us, I will make a really... Hi, Carmelo, are you here?
Hi. Yeah, I'm here.
Great. We cannot see you. We hear you perfectly. Yeah, for the moment, we even can see you. Amazing.
Okay, great.
Hi, nice to see you. Where are you now?
I'm in Barcelona now.
Okay, so we are like connected from different parts of the world. This is really
great.
Amazing. So yeah, I started the presentation of our educational program that we are having, and the program is called Urban Modularity. And actually, our initial idea was to make a series of offline events, inviting you, Carmelo, and many different professionals from all over the world to Moscow to have a series of lectures and a series of workshops on digital fabrication offline. But unfortunately, now we are this situation and all the world in this crazy situation with the virus, and we are locked down at our homes. And we decided not to stop the program and give the opportunity to people from all over the world to meet, but not in offline mode, in the online mode, and to continue this discussion, collaboration, and not to stop our activities. And I think this is what all the world is doing now. And actually, the main idea of the program is that how we can use digital fabrication in cities, which is the future of digital fabrication, which is the future of 3D printing technology. Specifically, Anna and Anton, who are curators of this program, are going to experiment with ceramics 3D printing. And I think there will be other speakers who will be talking about this more. And while we're here, I would like to say that the next weeks we are having other amazing speakers, and my colleagues now in chat will share the link to the website of the program, all the educational program, where our listeners can check up and join other lectures. We are going to have speakers from Denmark, from UK, from Italy, from Germany. So I think this will be a quite interesting discussion, an overview of the approaches, how we use digital fabrication in cities, and how we can even rethink it, because now we understand that the world that is to come push us to think in a new, more innovative way, I would say.
Sure.
Anton, thank you for sharing the link. And while I'm here, I would like also to ask all the guys who are now connected with us to put something in the chat, to say hello, to say your name and from where you are, because this is really interesting all the time to know from which part of the world people are connecting. So guys, please put in the chat like your name and country and a city from where you are joining us today. That would be great to check. And I'm really happy to present Carmelo, who actually we had a pleasure to host his lecture around a year ago in Moscow in Shukhov Lab. And Carmelo now, as he said, is in Barcelona, located in Barcelona, and he's the head of design in the external references, which they're doing quite interesting things in architecture, in design, in digital fabrication as well. And I'm sure that today Carmelo will share with us the crazy and interesting innovative projects. So I'm glad to present you, and I'm glad that you had an opportunity to join us. So let's start. Thank you.
Okay, thank you. I share my screen. Can you hear me, right?
Yeah, we can hear you. I will switch off mine, but we can hear you.
You can see my screen, right?
For the moment, no.
You can? No?
Switch off your video as well, because just to have a better connection, if it's possible. Yeah, now we can see your screen. Yeah, it works.
Okay, if I go to full screen, can you see it or not?
Now it's not full screen.
It's not full screen.
Now, yes. Now go back.
Now
it was okay. Yeah.
Ah, it was okay. Okay, so now it's okay, right?
Yeah. Amazing.
Okay, thank you. So first of all, I would like to thank Shukov Lab for and you, Nadia Kort, the general manager of Shukov Lab, for the invitation. And also, I'd like to thank my team. Without my team and the member of this team, all these projects I'm showing you were not possible. So thank you very much for the effort, especially during this these months that are quite tough with the work remotely, etc., etc. So the lecture that I prepared for today is mainly a professional lecture with an introduction that is more theoretical, and it's something that I like to do when to try to systematize what we're doing at the office. And so let's say that I'm a PhD architect, so for me the theoretical dimension of the project is always fundamental, because I think that practice and theoretical activities are informing each other. So the two videos that are showing here at the moment are showing the same material, which is Carrara marble, and two different technologies. On the left we have an artisan using specific tools under the control of his skills and experience. And on the right, we have a robotic arm driven by data. The Greek notion of techne condensate the theoretical process of design and the physical process of making. Can you see the slide now? I don't know if you have a delay. Is it working? Yeah. Is this what you see? Well, I don't see any interaction. Just want to be sure that you see what I'm.
Yeah, we can see. I think it's like it works amazing. Just go on. We
okay,
see.
perfect. Okay, so so I was saying that for Greeks, techne was integrating both concepts, of episteme and techne, where there was a very strong relationship, between both things, between the practical domain, but also the theoretical knowledge. That's why, as I was interested in technology, I started to read philosophers like Heidegger in his The Question Concerning Technology. And in this essay, Heidegger proposed that techne is not primarily concerned with assembling, making or using tools and machines, but rather with the phenomenon of revealing. Therefore, technology is not mere means, but a way of unveiling, of bringing forth. So it belongs to poiesis, to the creation process. In the book, The Life of Forms in Art, Henry Fosillon vindicates the relationship between technique, tools, and materials and formal generation. So the shape is suggested by the material and the technique used. This doesn't mean that the form follows a sort of mechanical determinism, but that each technique obeys its own laws that act upon the matter, suggesting a specific formal development. And formal exploration is rather a consequence, or it is intrinsic to the same material experimentation. So the Otto's tensile structures wouldn't be possible without this inseparable integration between theory and practice, without developing a design methodology based on the material behavior of light membrane. So each technology and material suggests and help develop a specific design methodology. It is not just a means, as we said before, to build something preconceived, but is a key element of the design process. And somehow technology is dictating, is forcing you to develop a new methodology of design. So what we see here is, this is Casa Seyrac, is a modernist building in which we first made a design of the interior space of this area here. This the first floor, and then we moved there to. We just moved in the same office that we refurbished. More than office, is like an office club, and as you can see, it's a modernist building, and in Catalonia, modernism is an Art Nouveau, that was taking a different naming, like in Italy's Liberty, and the most important representative of this architectonic movement is Antoni Gaudí. And as you can see, all the morphology of this building are taking into consideration this idea of nature-inspired forms. And so we really took into account these morphologies, natural morphologies, and the studies of modernist architecture to design a kind of furniture which is 2.0 modernism. And here we can see how the new technologies are allowing us to reproduce or to let's say push forward the manufacturing through a computer-aided process. And without this kind of technologies, generating this kind of morphology is almost impossible, because part of the manufacturing, handcraft manufacture has been lost, no? So this kind of process requires a deep understanding of the technology used, and only through prototyping and simulation we can push the boundaries of these 5-axis CNC cutting machines. Here we see, so first of all, we try to approximate the shape of the fins that are generating these elements, and then we reduce the amount of process under the 5-axis machine. So here is when we are refining the final shape. So the machine is going several times. This is the first prototype, and this is the toolpath pattern on the piece. Here you can see how the process of refining the shape is in process. Here we can see other images. This is the first piece realized after the prototype and you see here in solid, here in MDF, and here in solid wood. And this is the final when all the pieces are basically assembled. So you can see how all the ribs are joined together. And this is a meeting in our table. So this refurbishment was a pretext for us to develop a series of furniture, custom-made elements like this chair, which are again very much inspired by natural morphologies and modernism And in this case, we used Wear Pure Tech, which is a brand that was developing CO2 Pure, which is a 100% natural mineral compound with the property of mineralizing greenhouse gases like CO2 or NOx, and reduce volatile organic compounds like VOX. And anytime we are using 3D printing, we are collaborating with Nomena, and this is the kind of when we are using additive manufacturing, we are using this kind of material, which is a PLA with this mineral compound inside. So we can say that 20 chairs are absorbing in 1 year 20 kilograms of greenhouse gases. So it's purifying the air with this big amount of absorbing features. No, so one chair is absorbing 1 kilo of greenhouse per year, and this series of mangrove in English furniture is represented by this table and by the chairs. So together, chairs and table are generating these furniture that are inspired by mangrove trees, and like a tree is absorbing CO2. Here you can see how we eliminate at the end the central piece just for showing the interiors of the table, and each one of us can have his own pad, so it's a quite comfortable piece of furniture. Here is in its own environment, and here you can see how everything is fitting perfectly with the same design. Here is another view of one of the meeting room of the office. This is the aesthetic that is revealing this kind of technology. And of course, that's why when I was telling you that these new technologies are generating or are dictating a new kind of methodologies in design, means that we have to know perfectly how the machine is working, to adapt our design or our concept to the machine. Whereas in this case, we were adapting a table that was having a different configuration because it wasn't split by 8 different pieces, but it was just one piece. When we realized the limitation of the machine in terms of dimension, then we came out with the idea of splitting the table in 8 pieces. And at the same time, the machine itself is revealing this kind of texture to the furniture, to this piece of design. And when it comes with fabrication, I'm also interested in the interrelation between the control over construction through digital manufacturing, but also the warm imperfection of the manual labor. So I'm also very interested in this dialogue between handicraft and new technologies or cutting-edge technologies. So historically, the constructive textures of bricks have always had a fundamental importance in architecture, determining innovative structure system. But as I was saying before, the profound change in architecture has reduced the manpower availability to achieve such complexity. So digital manufacturing provides the possibility to re-experience this complexity by replacing the lost craft capacity. And what we see here is a kind of comparison between the Karagan Twin Towers in Iran, built in Iran in 1053, and the Gallery of Winery Gantenbein by Gramazio and Kohler on the right. And here we see how digital manufacturing provides the possibility to re-experience this complexity by replacing the lost craft capacity. In other words, machine can help play dynamics of manufacturing or assembling. But also vice versa, no? We can being inspired by this new aesthetic that is emerging by the use of new technologies. And this is exactly what happened presented by Flagship Store when we designed this store 3 or 4 years ago in London. So we designed a space that represents the urban culture, and to do so we have translated 3 urban features in 3 specific feature of interior space. So the typical London brick, the yellow London brick that here became a wooden brick, the skate park on the bottom, and the neon on that are part of the urban culture on the ceiling. So especially bricks are playing the main aesthetic role within the space, and they generate these wavy surfaces that are integrating the showcasing of the display of sneakers and adapting to the irregularities of the space. Okay, so so we've seen how these bricks can be placed and assembled by robotic arms, by Gramazio and Colors, but in this case we are playing like a mixed methodology in which bricks are placed with CNC templates and at the same time manually. So it's an hybrid in which at the end both systems are informing each other again. So here we see a video. So, for us, part of the fabrication and the generation of this physical dimension implies also the introduction and the addition of a digital layer that we try to integrate into our projects. So, for us, technology is not only physical, but it's also digital, not in the terms of informing the production, but also to improve or augment the physicality or the physical dimension of the projects. So that's why in this case we added this. We had this huge trainer of 2.5 meters, in which we have a 3D mapping on top, which is showing the evolution of Air Max collection from the 90s to nowadays. And when we have to design for the same brand a store at Harvey Nichols, our bricks became a techno brick, so the entire wall works as a 3D pixelated screen. So what we see here is Harvey Nichols Knightsbridge, and it's a short video that is showing so every single brick has its own RGB LED that is working like a system of pixels, of course with a very low resolution, but is generating like a slow and very attractive effect of light. So in Harvey Nichols Doha, we have a more luxurious context. Therefore, we use marble as a material to shape the store, and we keep the same diagonal arrangement of shoe, but instead of bricks, we have a stacking of CNC cutting machine marble layers, which are resembling these rough, almost casually break elements, but they are still following this diagonal shapes. That is one of the elements that are featuring the brand. So now I'm going to show you an awarded project that was designed in a modernist apartment in Barcelona, and it is thought as a theatrical journey. So we get into this building, which is an old building that was left empty for more than 30 years. And we want to keep this idea of the history and the time passing by this place and leaving his own trace. So the idea is not to hide the sign of the time, but just to introduce some specific elements like artistic installation that are taking place, that are colonizing the space without covering the essence of and the history of the place. For that reason, it's taught as a theatrical journey, because every space, it was an apartment, and to transform an apartment into a restaurant doesn't mean to completely transform it in a different space, but means to make an interpretation of the existing building and transforming it in something different. So here, the chef, the Michelin star chef Jordi Vilà. So this project, made in collaboration with Churros, was an opportunity for us to experiment and combine handicraft with digital fabrication, spanning different technologies. The reception, for instance, is remind us Natural Science Museum, where different specimens are exposed. And in this case, the selection should be taught as an inventory of the Jordi Vilà chef ingredients. So this is like the mind of the chef, where we have these containers containing and showcasing different ingredients that can be resembled in his mind. So this is all the process of construction. Then we go through the spine. This is the fish spine that invades the hallway, opening towards the and separating the two spaces. On the right, we have the more formal space, and on the left, we have like a tapas bar. So here you see how this spine is separating the two spaces and all the components that are composing it. So this is a view of the hallway. This is an illustration showing you how we make this interpretation of a fish spine. Why fish? Because the 90% of the menu is based on fish products. So everything is an interpretation of this. So here we see, the two spaces. This is the tapas restaurant. Both are Michelin starred, but this is a more informal space. And here we basically design everything from the chairs to the sofa. Everything was custom made. And this is a view from the other side. So we have this mechanical separation that can have different configurations. And of course, the production of the spine implies a deep computational study of the morphology and its fabrication. The construction is based on scaffolding, a substructure of different ribs, and every piece is absolutely different. And also the inclination of the ribs change constantly. So all these are pictures of the construction process, and here you can see how we this is how we are kind of milling a pattern on the wood, a wood that is so we have this is the unfolded pattern of each ribs, and this is how we build it. So instead of curving the wood, we design a material like a composite material built on purpose to follow the curvature of the fins. So it means that whenever we need to bend the wood, we have this kind of pattern, and whenever we don't need it, it's flat, and this is allowing us to bend it over the structure, the substructure. So it's basically adapting itself to the ribs. And at the end, we have a veneer on top of everything. And this is the alchemia side. So we have here a strategy of revealing and hiding part of the existing decoration. So this is our floor, in which we have these CNC cutting panels. So we're playing with plywood. Plywood has this characteristic of having different layers. So whenever you mill it, you show the inner layers. And so also here, for reducing the timing of the machine, we approximated this path, this pattern on the plywood with this milling with a spheric shape that is following just path. So instead of going with a very small one milling, we're going with a big sphere that is easily generating this kind of shapes by just following some path. Then, of course, you have to finish the panel by hands, and this is how 3 panels look together. So even the connections are not straight line, but are lines that are following the same pattern of lines. So this is a view of the restaurant from the hallway through the formal space, let's say, and this is a view from the other side. This is how the panels on the walls and on the floor are in relationship. So we have an illumination here that is illuminating the walls, specific elements, and these are inspired by fish schools. So we have this kind of abstract fishes that are showing lights and showing specific details of the 60 space. So even tables and all kinds of furniture were designed by us. And here we are working with 2 technologies for building the legs of these tables. Firstly, we 3D printed the legs, and with the 3D printed of the legs, we made the first mold. And this is a sand mold technique in which the mold is the positive. We make the negative out of it with this special sand, and then we close the 2 elements, and we pour the aluminum inside of the mold when the two sides are closed, and then we take out the leg. Of course, when you take out the leg, then you have to you have to polish it, you have to clean it, you have to cut. So there's a mechanical intervention on it. And these are the legs almost ready to be assembled. Here also you see different kind of samples for the finishing of the boot. So for the chair, a similar strategy was applied. This was 2016, I guess, or maybe earlier. And what we did here was, at the moment, 3D printing, it wasn't very common, and the only available 3D printer were very small scale 3D printers. So we had to split this chair in many pieces, which is something I don't recommend, because when you try then to assemble them, it's not very accurate. But this was we were starting with this process, so we learned a lot by assembling these pieces together, then coating them, and then from these we get to the other one, that is the stool. And once we have both pieces together and they are coated, then we can make the first mold. So the first mold was coming out from the 3D printed elements. So you made the positive, and from the positive then you make all the rest. And then here we have the another special piece of furniture, which is the J bar, which is a bar that is resuming different tasks, like ice pot for depositing bottles and keep them fresh, drawers, and different trolleys that can be placed in the space. No. So here also it was quite tough to make a piece of furniture with this shape. We work with these different ribs, and then we clad everything with this piece of metals. And at the end, we polish everything, and the result is quite clean and beautiful. So here you can see how all this is made out of the same material, but using different technology. So we used 3D printer for the legs and of the tables and the chair. The top of the table was realized with traditional carpentry technology. This was made by using laser cut technologies and handicraft by bending manually the sheet over the ribs. The sofa was also built with the CNC cutting machine, and all these dots that you see here are like three-dimensional elements that we did by casting aluminum. On the right, we have glass-blown containers for showcasing a series of food saved in this wall. And ultimately, on the top, another kind of technology that we were showing you before. So coming back to presented by, which is our great client. They asked us to design a shop for Dubai Mall, for the Dubai Mall, for level shoes actually, and it's a project in which Sebastiana Morelli was working very deeply, and now, as you can see, everything is completely wrapped by a 3D printed walls. We are still keeping this idea of diagonal shoes, which is one of the main features of the brand. And here you can see how the sneakers are exhibited. And now we already started with the production of these 3D printed walls. And now we go to the Spanish Pavilion, which is a project in which that we did in collaboration with Onion Lab. So we are associated with them for developing this project. They are we are more into the scenographic and physical configuration of the space, and Onion Lab is working more on the audiovisual content and interactive contents. So this is a project in which everybody in my office worked, but Amin Bigdeli was like the one that was pushing really a lot. So I want to thank him for this project. And as you can see here, we have a very clear concept. We want to generate a landscape. It's of course it's an artificial landscape. It's a techno forest that is representing Spain. So it's just one of the space of this pavilion, but I just want to show this space because it's one of the most spectacular, and it's more related with advanced technologies. So it's a techno forest, as I said. Is the exhibition of the Spanish Pavilion for the Expo Dubai 2020 that will be moved to October 2021 due to COVID. And what is interesting in this project is that we want to represent Spain with this forest. No, so why forest and Spain? Well, forest is we have in Spain a beautiful forest, and Spain is one of is the country with an incredible amount of a natural landscape protected and recognized worldwide. So that's why we use a forest because the Irati forest is a beautiful landscape that we want to use here to represent the latest technologies in which Spain is working, the new startups, and the new achievement of Spain in many different sectors, from food technologies to energy technologies, and etc., etc. So we are doing it with a landscape that is artificial, but it's work by behaving like a natural one, because as you've seen before, we are using CO2 pure, so we can absorb CO2, we can absorb NOx, VOx, and we are also producing a very considerable amount of oxygen with the use of these photobioreactors, generating a big amounts of oxygen into the space. So a strong digital dimension is animating the project with holograms and 3D mappings and different transparent screens that are showcasing different contents. I cannot reveal you more details of this project because it's a quite confidential one, but this is one of the main features of the project, a tree that is responsive with ecological footprints and behavior of people. In any case, I invite you for the next year to join us in this marvelous pavilion in Dubai. And here is how we are already started with Nomena, the prototyping of these elements. So as you can understand here, now we are taking advantage of the deposition of the material to generate this kind of morphology and texture into these trees, and these are a kind of technology that we also are accustomed to use at IAAC, which is the Institute of Advanced Architecture of Catalonia, where I'm teaching the House of the Future, a studio that I lead, and in collaboration with Sebastian Amorelli, and where we are leading the House of the Future. I will show you just this project, but I think it's a good example to show you what we are working there. So in this project, for instance, we are envisioning a society with no properties, where everything is shared. We are in Hong Kong, where we have a problem of overpopulation. So dealing with the house of the future means to face the consequences of overpopulation, lack of housing, land scarcity, etc. So this project is speculating on the use of artificial intelligence, and in this community where everything is shared, we are parasitizing an existing cluster of buildings, of skyscrapers, and you as a customer, you don't own anything. No, you don't own nothing. So, but at the same time, you own everything. Why? Because you can get the valuable space which is managed by artificial intelligence. So you can live wherever the capsule is available. So we have this kind of 3D matrix that is parasitizing this building, and in which we have this system of cubicles, of capsule that can move along the 3D in this matrix. And the project is questioning not only the idea of ownership, but also it moves forward the paradigm of construction. So construction is not the end of a process, but is a never-ending sequence of possibilities and configurations. So if we need a public space, the capsule are moving, and this is within the capsule. Also here, the idea is very radical, no? So we have like micro robots that are generating whatever your furniture profile is dictating. So everything is highly custom made, and everything is assembled and reassembled. So this is an overview of the project. Here you can see how we also are dealing with robotic arms that are always for maintenance and for building and constructing things. And these are like open space areas that can be colonized. So of course it's an utopic and a very radical idea of living in the future, but I think it's important that we start to do so. So this other project is a landscape staircase, is a public space connection that is again parasitizing, in this case, the dam of the coastline of the city, and this is a cloud point survey to ensure the precision of the execution. We have a simple structure that is allowing us to connect these two sides of this plaza with this other plaza elevated. This is the dam which is existing. So it's a cloud point survey is fundamental, mandatory to make this kind of design, where everything has to requires the precision of the millimeter. And so we have this structure, this metal structure, and in these we have these panels that are going to cover it. This is a view from the night, where you can see how the cladding perforation is emitting light during the night, and this is a view during the day, in which you can see that at the same time the skin is made out of bioreceptive concrete panels. And these are the drawings of constructive drawings that are they've been using for the precasting process. So of course we deliver 2D drawings, but then the company are using the 3D models to generate more than 20 different molds and to generate these concrete panels. Okay, so now we go to from Spain to Thailand. We are here in Bangkok, and this is a close-up of a building that we opened a few months ago, and it's a project done for 24 Quilates, which is a Spanish brand that is that moved in the past years to Bangkok. And this is a building that is that has different levels of interpretation. It's a refurbishment first. So what you see is a scheme that is wrapping an existing building, but is also making a kind of relevant intervention, like this hole into the facade, which is also playing the urban dialogue with the city. We want to make a project that is really that it looks like an Asian project. 24 Quilates is a brand that is selling quite exclusive trainers, and it's a brand that is playing with this rule of luxury. So 24 Quilates means 24 carats. So it's a gold. They are treating their products as they were jewels. So that's why we were making this association of luxury with the mechanism, and of course one of the first. So here you can see the complexity of the facade. And we have many layers that are playing with aesthetic roles. We have LED screens that are wrapping part of the facade. We have CNC cutting panels and stainless steel laser cut panels that are interconnected. And these are the interiors of this mold building, where we concentrated a very impactful design. So here it's all about experience, and this experience is in this case revealed through the intricacy and the complexity of these mechanisms that are they're representing the metaphor of luxury and precision and high exclusivity. So here you can see how you can discover your sneakers within the intricacy of these mechanisms. This is a view from inside toward outside. Details of course, this is a project in which we have to thank, first of all, Stefano Fontolan, who was not only working on the project, but he was also supervised the construction. And I can tell you that supervising the construction in Thailand wasn't an easy task. So here you can see all the details, but in this project was also working like here Francesco Sacconi and of course Jacopo Neri, that was working with these swarming vectors that are wrapping all the surface and are generating different supports for t-shirts and all the apparel that are showcased in this space. These are some details of the intricacy of these roads, and this is a video that is condensating And then just to just a quick recap, I want to recap with a short video about our company, External Reference, which also recently, well, in the past year, opened a branch in Moscow, and was represented by Alexei Martinitsov. Many thanks. So I guess that we can go for the questions.
Hi, Carmelo. So thank you for the lecture, and
You're welcome.
that you and even small Russian. Thank you. Yeah, this is great. It was really interesting how you showed that those techniques and technologies can be implemented on a different levels. And one of our topics that we try to cover during this educational and research program, urban modularity, and is how we can replace different urban, so let's say models, using the means of digital fabrication in the city, and how even in a small labs all around the world. Historical architecture is one of your projects as well.
Part of your, Nadia, I think I lost you for a moment. Can you repeat again?
Can you hear me?
Now, yes, yeah.
Yeah, so I was saying that this is great that you've showed that these technologies can be implemented on different scales, starting from interior design to architecture to object design. Yeah, this is really interesting. And if you go to our chat, there are some questions. I can read it for you. So one of the first questions was connected with, I think, with the project. You showed the furniture, the table that was kind of as a mandar tree, as far as I remember, the shape of mandar tree. And there is a question: how much time did it took to print such a table?
I mean, we used a WASP 3D printer that has a capacity of a radius of 90 centimeters by, it's a block. I mean, yes, you can build like a block of 90 by 90 by 90. And this machine was producing one leg, I mean one element every, it requires almost 4 days per one piece.
Mm-hmm.
I think three days, if I'm not wrong. But then we had to assemble the different parts together, because every piece is just one piece, no? But then we have to put the cover on top, and you have to fix it, so it's fixed with some screws, and the joint is very clean because it's following the same texture of the 3D printing.
Okay, thank you. There is one more question. Could you please explain more about the influence of typology optimization process in your projects, amazing projects?
Okay.
Do you understand the question? Yeah.
Not very much.
Yeah, maybe the person who did this question, maybe you can comment a little bit more what exactly did you mean, because this is not much clear, and we can continue with this question. And while we are waiting some more comments about this question, Anna, maybe you can make yours questions, because I've seen you had a list of.
Yeah, how many people?
Yeah, I just can explain. Yeah. First of all, thank you for amazing lecture. And my question is about the architectural process as a whole, because this is crazy that you lead the process from design idea to manufacturing with things. And because I'm an architect and interior design as well, so this is very non-typical to produce like your ideas by yourself. So I have a question: how many people did participate in this process? So is this about fish project, for example, fish restaurant?
Yeah, okay, so the fact is the following: we don't produce personally these things, no? We are collaborating with different people, but of course we are working as a contractor with some of our clients, so we deliver not only the design but also the construction. It doesn't mean that we personally have to work there, no? I think nowadays we have to learn how to collaborate and to create a fruitful network of very competent people, and grow together, no? So it's a feedback loop in which you learn from the producer learn from yourself, different providers, and at the end you make a team. So what is important in architecture is to be able to coordinate and to lead different people with different skills and working with the same goal, no? And as a project, a really exciting project, and we always try to push the boundaries of the project and of fabrication forward. These make things more exciting, and people are more engaged, and you know, it's about passion and doing things that you really like.
Yeah, collaboration is the key. Thanks.
Yeah, collaboration is the key, and so that's why we are collaborating with many providers. But of course, in this kind of projects, in which, I mean, the digital fabrication is reducing, the distance between designer and the object. No, you don't need people that are making interpretation of what you're doing, because it's the file itself that has all the information to be printed or to be milled. Nonetheless, machines have specific peculiarities and limitations, so you have to make a final refinement of this file, and this final refinement can be either done by our team, or, as it's happening most of the time, by the companies that are collaborating with us. It's just a question of time, and specialization. I mean, what we are specialized in our office is in not being specialized. So we like to work in different fields, and this is one of our strengths. Also, we work from big scale to small scale, spanning different fabrication methodologies.
Great, thank you.
You're welcome.
I also have one question. So you said that, for example, the production of this furniture took quite a lot of time, and how do you think, what is the perspective of using digital fabrication technologies, but more, I would say, in a mass production? Of course, for the moment, we have several examples that different different machines are being used on fabrics for furniture production, etc., etc. But if we're talking on a more customized, I would say, furniture or urban elements, for example, how do you see, which are the limitations of using those methods, I would say, in a more mass productive way, and how do you see the future of this trend?
Okay, it's. I think it's the question is the following. No, you can have you have pro and cons with every system. No, from one side you have the mass production, and on the other side you have the custom production. No, on one side you have you produce volumes. No, and on the other side you produce differentiation. So I think that it's not a time for mass production. For instance, for the world of the chairs, why we should design a new chair? No, there are so many chairs. Why we should design a new chair if we have so many? In our case, it's just because we want to. I believe in a very small and reduced production. No, it's something that is customized for specific clients for specific project. So also for the urban design, I believe in context design elements. No, so even in the urbanity context or in the private context, I really believe in that each project should be site specific. And which is something that is a little bit going against the idea of globalization and project that can change its context. No, so let's say, of course, some projects, some elements can change their context. But for instance, this chair was designed for that context. No, it's a modernist building with a table as a very specific context, which is informing that design. Then it doesn't mean that we cannot take this design and put it somewhere else. But the idea of that elements is that was thought for one client and in one context. So it's not thought to be designed for everything. The same is happening for the staircase. No, so the staircase is an urban element that is taking place in a specific place. A specific place because it's is growing beside an existing dam, so we have to take into consideration the geometry of the existing context. We have beside the dam we have a lot of blocks, of concrete blocks. So the idea is to bring these blocks in and to make a kind of topographic staircase that is connecting the both sides. So of course, we can make a triangulated staircase in another place, but that staircase is for that place. Then, so I think that customization is the future, and is a future in which we shouldn't, where the problem of volume should remain in the production that is already existing, which is the mass production. Of course, then we can say, okay, but it's important there are emergent countries in which we have to build housing. We still have the problem of housing. So, so in that sense, of course, machines are together with the parametric design and probably artificial intelligence applied to the to these design methodologies and fabrication. They can speed up the production, and at the same time they can be like a mass customized production. No? So maybe this would be the future of bespoke design being embracing, I just say, that can embrace volume and a big amount of items. So replying now to Anton,
okay.
Yeah, replying to Anton, the chair was just one day for the chair.
Yeah, so I think this is it with the questions, and I really would like to thank you for sharing your experience and your project. We had people with us today from Germany, Ukraine, from Peru, Ecuador, Kuwait, Iran, Russia, India, so from many places of the world. I think the geography is just amazing, and this is what actually these online events give us the opportunity to meet, being on so different parts of the world and to share our experiences. So thanks a lot, and if anyone has questions to Carmelo, we are always open, and you can contact us through our social media, through Instagram, through Facebook of Shuhov Lab, and we always will be really happy to send those questions to Carmela. I know that Carmela has a quite active profile on Instagram as well. You can find him an external reference, the bureau itself, in Instagram, and go directly to their page and check the project that they do. And I think that this is great that we have the opportunity to share all the experiences that we have. So thanks a lot for being today with us.
You're welcome.
And I hope you really enjoyed the event.
Thank you. I hope to see you soon in Moscow, so we can have another presentation there, because I understand that this web meaner and social distance is nice, but I think it's nicer to come back and having real, face-to-face conferences.
Yes, yeah, thank you very much. We really will be happy to see you in Moscow as well. And everyone who is here today with us, I'll invite you to our next webinars the next weeks on Tuesday and on Thursday. We will announce everything in social media, and you can go also to the website, which you can find in the chat section. My colleague Anton has sent it earlier. So we'll be really happy to see all of you with us on next Tuesday. So thanks a lot, and goodbye.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Bye.